I will start. So, good day, audience. Come on, come on. So, um, this is another episode of our show, and I'm here with the departmental president of physics, Namda Azikiwe University. Mesoma, say hi to the camera. So, she's the first female president of physics department in Unizik. So, can you tell us like how you got into the position of being the first departmental president, first female departmental president of physics?
Okay, my name is Uzekome Somalilian,
Yeah.
and let me say I like physics though.
Okay.
Initially, I did not like physics,
Mm.
but I love physics along the way. During my secondary school, I was, if you see the last position, then you see
Eh.
me
Wow.
in physics.
Oh,
So,
which secondary? Did you go to a private secondary school or be a
so
private
I
school?
went to a Catholic school.
A Catholic. Like,
Uh,
okay.
so
So,
I did not like physics initially, but
okay.
my uncle then was like, I should leave. I wanted to put computer actually,
Mm.
but I've already put computer. He was like, since I've already put computer, I should put physics as my second choice.
Mm.
I now added physics as my second choice
Mm.
before I now got admission into
Mm.
Unizik as a physicist.
Wow.
So
So, how did that transition from you to being the president of physics in
okay,
Unizik?
I started liking physics along the way actually
Okay.
because it's something I can see, something I can bring home, something I can understand, something that is happening
Mm.
around me.
Mm.
So I started loving it gradually. I was like, I'm already in the department, I cannot do anything again.
Yeah. So you had to just like flow.
Yes, so reaching my final level, I was like, I would love to be the president of the department.
Mm.
So elections was conducted and I emerged as the president of the department because it gave me more insight to it gave me more opportunity to meet people, make connections with people and stuff.
Now that's an incredible story. Incredible story. So what aspect of physics do you enjoy more? Like what's the direction of physics? I know that okay, this is me, this is where this is what I
Okay.
like.
For me I like nuclear physics.
Nuclear.
Yeah.
Oh.
I like quantum. Not that
Mm.
not that much.
Mm.
Then I think I also like geophysics, but it's not really if I want to measure, I think I'll go further more on
Nuclear
nuclear
physics.
physics, yes.
Wow. Wow. Okay. So that is sad because like this podcast now is majorly about quantum physics.
Yes, it's no
So
physics. Every physics are related actually.
uh,
Even in nuclear, still need quantum. So it's not like
okay.
I can run away from it.
That's thank you. That's all. So okay, I've talked about how you go into physics, then how you became the departmental president of physics in Unizik. So how are you enjoying being the departmental president of physics? Like what is your goals? Like what do you intend to do about the department and stuff?
Okay, I will not say it's an easy ride actually,
Mm.
because it's very tough, very tough. It's kind of like you have double responsibilities actually.
Yeah, that's crazy.
Yeah, you have to dedicate your time, even yourself, self. You not have free time
Mm.
the way you had before.
Mm.
But since I took up the position, I was like, I'm the one that took it up, so I have to sacrifice my time for the department.
Mm.
It's not really easy though, because you are the intercessor between the department and the
Head and the
students.
students,
Yes.
yeah. So yeah, that's a lot of that.
There are some times where complaints might come to you that you cannot handle, and the pressure will be on you from the department, from the students, and you have
Mm.
to find a way to solve it.
Mm.
So I will say it's not an easy responsibility, but I think I'm liking it.
So what is your goal? What is your future goal in the department? What do you intend to which mark do you intend to leave for your predecessor?
Um, I would love them to focus more on, if it is possible, focus more on applied physics, because we
Apply.
just know the theory, but we don't really know.
You don't like apply it, yeah.
Yes, so
Okay.
maybe in the future we can get collaborations
Mm.
from different companies. Or I wanted to actually do something, but
Wanted to actually
funds. I actually wanted to do something,
okay, do something,
but
okay.
funds and time was a limiting factor. Like
Okay.
bring a physics research center
Mm.
actually to here, but no. acquiring land, funds to build it. So
Yeah, and the department
I've
is
checked. It's
yeah.
not something I can do on my own. So I did not actually venture into it. But if I have the money on the long
Mm,
run, that's
mm,
what one thing I would do.
okay. So now I want to enter deep down into quantum physics now. Are you ready? So now like you need a loud voice, like you need to be audible because the mic might not capture this. So we are talking, you need to be a bit loud. So yeah, can you like give us, I don't know, just give us illustration of, give us like the history of quantum physics, like from there on entering. Like what do you understand by quantum physics? What is quantum physics? How did quantum physics become quantum physics?
I would say quantum physics came into reality because of the shortcomings of classical physics.
Okay, classical physics.
So classical physics could not really explain what really happens in atomic levels. It
Mm,
really explains only matter in a bulk level like planets,
yeah.
houses.
Mm,
Does not really boil down to what happens at that level that we don't actually see with our naked eye.
mm,
So that gave rise to quantum physics. So now so quantum mechanics is
mm.
kind of like a principle, or let me say, yes, it's a fundamental principle on the physics that happens in the subatomic level that we cannot see with our naked eyes.
So that's like electrons.
Yes,
Yeah.
electrons, atoms,
Okay.
molecules,
Okay, all those kind of things.
photons,
Yeah.
yes.
Okay.
So it gave rise to quantum mechanics.
Mm,
So scientists like Bohr, Einstein, Schrodinger,
yeah.
they were like they saw some things that is not meant to, it's not a natural phenomenon. They were like, for example, um, using
Rutherford.
Rutherford's model of
Okay.
this thing, he said that electrons will orbit around the nucleus,
You
and
said
for
electron orbits around the nucleus.
yeah, sorry, orbits.
Yeah, around the
It's
nucleus.
like a circular path now,
Mm-mm.
orbits around the nucleus. Then,
Mm,
when it loses energy, it
mm.
collapses inside the nucleus.
Okay.
But something like this was not happening.
Okay.
So they were like, "What's really happening?" You get. So
Okay.
that gave rise to these scientists figuring out why is this
Yeah.
electrons not collapsing inside the
Okay. When they are
nucleus.
moving, why is it not that they are
Yes,
collapsing inside?
instead they are stable.
Yeah. Okay. Okay. Okay.
So
Okay.
what is really happening? So
Okay.
that's also part of what gave rise.
To
Let me say
quantum.
it's kind of the major part that gave rise to quantum. So they started
Okay.
investigating and found out that instead, when electrons gain energy,
Mm,
when they are at the ground state and they
mm,
gain energy, they
mm.
move up to a higher level,
They move.
from a lower level to a
Yeah.
higher level.
Okay.
When they lose energy from
They
that
come
higher
back.
energy to,
Okay.
instead of collapsing into the nucleus, making it stable,
Okay.
you get.
Uh,
So we also had
sorry. Who discovered? Like, was it Rutherford that posed the question, or who posed it that like why does electron not collapse when they are moving around in the nucleus?
I think no, Rutherford came with the theory that
Mm.
electrons revolve around the orbit.
Electron reverse. Okay. Okay.
Yes,
Okay.
and when they lose its energy, it collapses into the nucleus. But I think
Okay. Okay.
Niels Bohr came up with the theory that
Okay. Okay.
it does not do
Okay.
so.
Okay. Now, okay. 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 So yeah. Okay. I think you have explained um the foundations basically of quantum
Mhm.
physics. So why do you think classical mechanics or classical physics don't explain this quantum mechanics?
No, classical
Uh,
mechanics is more of Newton's law of motion.
mm,
This with electromagnetism.
yeah.
But most of these things, it just deals with bulk acceleration, like
Okay.
let me
Big.
say
Big.
body
Yeah.
accelerating. It does not really talk on this
Okay.
the small things that we don't see. You get.
Okay.
Uh, there are some okay. For example, classical mechanics will tell you that when when something is being heated up,
Mm,
when a metal is being heated up
mm,
at high frequency, it is
mm,
meant to give out infinite sum of energy at high frequency.
mm.
But quantum mechanics was like, no, it wouldn't. Because there are some times when when lights are hit, let's say, this is a metal now, and
Yeah.
I hit a light on this metal.
Yeah. You like you incident lights. Okay. Yeah.
Yes,
On the metal. Yeah.
light is incident on this now.
Yeah.
Instead, it does not give off, let me say, electrons are not being knocked off from these metals
Okay. 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 Okay.
upon up. like
upon
upon
the incidents.
they have high frequency.
Okay.
So they were like quantum mechanics is like why is electrons not being knocked off
Mm.
when they
When light is incident on it.
yeah when the light incident on it has high frequency.
Mm.
That was the question classical mechanics could not answer.
Okay. So does the question have answer now?
Yeah, it have answer because it is being said that
Uh,
light comes packets of energy called photons.
okay.
So okay, for example, now when a blue light is incident on this
When
is a
it,
metal,
yeah,
for
yeah, okay,
example.
here's the metal,
So
yeah.
when a blue light is incident on this metal,
Mm.
it will knock off electrons because it has high energy. But
Mm.
when a red light is incident on this metal, it
Mm.
does not knock off uh,
Okay.
it does not knock off electrons. Why? It has low energy in as much as it has high frequency.
mm.
It has low energy.
Okay, yeah, yeah, yeah. That's like the spectrum, electromagnetic
Yeah,
spectrum.
the spectrum.
Like, okay, there's something I know. I don't know if it's Einstein that said it. He gave one physicist, renowned physicist, a Nobel Prize. Um,
I think it's Niels Bohr.
is it Osborne? Like, there's a name for it. I'm looking for that name. I don't know where I
Is
wrote
it
it.
and
Um, I think is that the double slit experiment?
the double split?
Double slit experiment.
I don't really think so. But I think it's Niels Bohr.
Okay, that's what I explained the phenomenon of electron being knocked off. I'm thinking it's Albert Einstein.
Mm.
Um, electron knocked off. Did you see it?
I know that somebody was given a Nobel Prize.
For this
Yeah, it's
experiment.
Bohr.
It's not Bohr.
Yeah, in 1922.
What's the experiment called?
I think he said he received the first quantum model of Bohr's atomic model was the first quantum model,
Mm.
and he received the Nobel Prize in physics in 1922.
Yeah, like I'm talking about the phenomenon of electron being knocked out when
Is
there's
it
energy incidents.
photoelectric effect?
That photoelectric effect.
When
Okay,
when light
yeah,
is being hit
yeah.
on
When like
metal, yes,
is that not the stuff you're explaining?
yeah, photoelectric effect.
Is it Niels Bohr that did that Albert Einstein? I thought it's Albert Einstein.
That did photoelectric effect.
Yeah. And I'm thinking like they gave Albert Einstein the Nobel Prize for it. Let me check it. Who got Nobel Prize?
I think Einstein and no and Bohr. Oh, Bohr. I think Bohr was more
Uh,
energy, at electrons losing its energy.
uh,
That was what Bohr.
okay,
That was the first thing that gave rise to quantum.
actually, it's Albert Einstein
Yeah,
that is
but
like
I think
1921.
Bohr also got. But I think he was the first person from that. This thing I said
Mm,
that electrons does not collapse in the
mm.
nucleus. So I think it was his first theory that gave rise to
Okay,
people
talking
speaking
about
about.
Albert Einstein and Bohr. From what I read from my research, like I figured out that Albert Einstein and Bohr they were like enemies in a sense, like because they did not agree. They had different intuition of
Mm.
quantum physics. They had different definition of quantum physics. Is that something like you encountered when you are doing some research?
Okay, yeah, they said
Uh,
Bohr said that
mm,
quantum mechanics is enough. That there are some things, there are limits to what
mm,
nature can do. We cannot know everything
mm,
you get. So, but Esther was like, there must be some rules, guys. That something cannot just happen.
mm,
That something will prompt something to happen.
mm,
So that was
mm.
the major foundation of their disagreements.
Okay, okay, okay.
Yeah, that was the major thing.
Okay, that's interesting. So, moving on, this is just like a genuine question from me. This is just a question for me. Who can you say is the father of quantum physics? Who can you like give that title to?
I will really say Schrodinger
Schrodinger.
in my own aspect.
Why? I would say Max Planck, but why
Yeah, I
Schrodinger?
know Max Planck, but
Uh,
I think Schrodinger made it kind of for me
uh,
because he brought out mathematical model
mm,
for us to, it's using this Heisenberg uncertainty principle that we cannot actually know the position of
and momentum at the same
yes at
time.
the same time.
Mm,
So I think Schrodinger brought out something we call wave functions.
Okay, Schrodinger was one that brought wave function.
Yes.
Wow.
It's, I
This we
think
knew that.
yes, the square of wave functions. That
That means
size
okay,
square something.
was Schrodinger ten or before Albert Einstein? Was he like because I know Albert Einstein used wave function. I
No,
should
it's Schrodinger now. It's Schrodinger's equation.
okay, that's well, okay. That's where
Yeah,
function
wave
emanates from.
functions is from.
Wow. So can you like explain what wave function is for the viewers that don't understand?
I won't really say much, but what I understand from wave function is
Mm,
that it's a mathematical model that Schrodinger came up with to allow us know the position of a particle
okay.
in a given, like, let me say now, for example, now
Mm,
let me use this ceiling fan now.
okay.
We cannot really know the position of one blade and the speed of it at the same time.
Yeah.
So if you want to know the position of one, you lose
Mm,
the track of the speed of
yeah,
the
yeah,
other
yeah,
one. And if
yeah.
you want to know the
That's
speed
also
of the
associative
one,
principle.
yes.
Okay.
So using wave function can now derive the position
Uh,
of the
of
particle.
the particle.
Yeah.
What about the momentum?
I
Oh,
think it's still it's still
okay, still being researched upon.
I think
Okay,
what's this
okay,
position?
that's very interesting. Like I just learned something new today.
Okay.
I didn't know Schrodinger was. So all those box Schrodinger equations is usually just to find the wave function. Like what is that Schrodinger equation? Like what is the resulting factor of that Schrodinger equation?
Okay, let me say something like this. They said particles behave as matter and
Yeah.
as wave.
Mm.
So in some when it behaves as let me sorry,
Who gave that
we
particle
have
behaves as matter and wave?
particle
Uh,
duality of
Albert
matter.
Einstein. That's Albert Einstein.
Uh,
I think it's somewhere. Okay, it's not here. Okay, is it? I saw it was. Okay, I think it's in our
it should be in the physics lab.
physics lab. Yeah. Okay.
So I would say
Mm.
this thing called duality of matter.
Yeah.
A particle behaves as matter behaves as is it particle and waves or
Matter behaves as particle and wave. Yeah. That's duality
yeah.
of matter. Yeah.
When it behaves as particle, it
Wow.
comes out in chunks. But when it behaves as waves, it spreads out. So that way functions. So like when it spreads out, like let me say, now,
Mm.
what even one of the things that also prompted people to be intrigued by quantum mechanics is that this thing called tunneling.
Quantum tunneling.
Yes, quantum tunneling.
Wow.
Let me say I have a box like this and I
Mm.
place something in it,
Mm.
but the box is still being able to pass. Like this is a box, I have something in it.
Okay, this is a box. Yeah.
Yes, I have a ball in it,
Okay.
but the ball is still able to move outside of the box without actually causing damage to the box.
Okay.
You get?
Is there any way you can like create in the body?
Let me see
Like
something like
just
this. I have a ball like this now,
yeah.
but the ball is like this is a barrier,
Okay.
but the ball still have the ability to
Pass through this
tunnel
barrier.
through and pass without actually causing damage to this barrier.
Okay,
So
that
that's
is
why
quantum
they say
tunnel.
yeah, it also behaves as wave.
Okay. Okay. Okay.
You
Okay.
get?
Okay.
So this
Phenomenon.
phenomenon
Yeah.
also intrigue people to know why something like this will pass without actually causing damage to the barrier. So
Wow.
that's where tunneling
Tunneling
was,
comes
yeah,
in.
the name comes in.
So
So
like this does not happen. Does not happen in classical physics.
no,
Wow.
it does not have a classical
Can you
physics does
explain
not have explanation.
for this?
Yes.
Wow. So is there any other like phenomenon that quantum physics can explain that classical physics can explain?
Let me
If this
say
tunneling, is there any other one?
entanglement.
Hmm.
Entanglement is something like
Is there a duster? Where is the duster? Sorry. Okay.
okay.
Hmm.
Let me say I think I'll do tunnel sorry, entanglement.
Okay.
Maybe I have something here, I have something here, but there's an invisible line holding it
Okay.
together.
Wow.
Anywhere, no matter it can be, this one can be in Alhambra, this one
Hmm.
can be
No
in
matter the
Kaduna, no
position.
matter the position,
Wow.
they are, let me say, magically entangled to each other.
Wow.
So anything that happens here automatically affects
Okay.
here.
Yeah.
Let me say, in a case of a coin now,
Coin. Okay.
mm,
Yeah.
so let me say these are two coins that are magically entangled. We don't really know how they are entangled, but we know there
Hmm.
is entanglement.
Hmm.
So in a coin, we only have head and tail.
In a coin, yeah, we have to
Yeah.
that too. Yeah.
So if If I flip this coin,
Okay.
I know it will fall in that head or tail.
Yeah.
When I flip this coin and this one gives me head,
Mm.
automatically this one will give me a tail.
Wow. Wow. Wow.
So
This
it's difficult. People are still trying to like know,
understand.
yes, why
Yeah.
it's happening. It's kind of like
Okay.
ability to, let me say, can I say,
Explain.
let me say, it's just like let me say like twins, for example, twins now.
Okay.
A twin,
Mm.
something can be happening to one, let the other one be feeling it. That entanglement, just let's bring it back to one too.
Mm.
So you get,
Mm.
we are still trying to,
Yeah.
tap
Okay.
into this and make good use of it.
I I would just like call this spooky action of a distance.
Yeah, spooky actions at a distance.
Wow. So what other principle? What other
Uh,
stuff can quantum physics explain that?
let me say, let me also use this coin. We have what we call one superposition.
Okay.
One two.
Superposition. Yeah.
When I'm flipping a coin,
Yeah. That's same
it's
coin.
still in the air.
Mm.
Let me say it's two things can exist at the same time. But then when you look at it, you can say this is this or this is this. Let me say for
I didn't get
example.
it.
Okay, let me say for example now, still making reference to this coin.
Yeah.
When I flip the coin and it's still on the air, it's giving me head and tail at the same time. That's what we call superposition.
Wow.
So when it now lands, I can now go and check and say, okay, it gave me a head. So that ability to exist at the same time too, you get.
Okay.
It can be either head or tail, and it can be both at the same time. That's what we call superposition in quantum.
Okay. Yeah. I want to like say something
Yeah.
basically, but this is your show, so
No, you can, you
I
can.
wanted to explain how all this like is important in quantum computing. How this makes a quantum computer faster. But let's just leave it for another time.
I think I really understand.
Okay, you understand how you
Yeah.
okay,
Mm.
can you explain?
So
For
I like bringing physics home. It makes it easier to understand.
yeah, that's true.
So let
And
me
yeah.
say I
Mm,
have a door.
okay.
I have a door and I have a key. And this is a box. I have like 10,000 keys here. Keys here.
Keys.
Yeah.
Okay.
But I want to find a particular key to this door.
Okay.
Let me say in classical mechanics, you can just pick one and open
You trying it
and
one by
drop.
one. Yeah, okay,
Yes.
okay, one by one.
But in quantum computer, it can pick both at once and
Simultaneously, yeah.
check. Yes,
That
simultaneously.
is
Yes. That's
superposition.
why I say things can exist at the same time.
That is
So it's something that would have been solved maybe with 1 hour, under seconds.
mm,
We've already solved it. So I think that's how this thing is being brought into quantum computing. My own
that is
idea.
I'll clap for you for this. I'll clap for you for this. So like okay, can you illustrate superposition and entanglement for quantum computing? Like
Superposition and entanglement. Can I?
okay, I think this is what we just did. This
I
is
think this. I
superposition,
think this is superposition. Yes.
but tunneling, and I have no idea of tunneling, but I know of entanglement.
Tunneling, like something like our HOD said once.
Okay, and there's something like annealing, quantum annealing. Is that
I've not heard it before.
yes? That's what it is.
Okay, there's
Mm,
something our HOD said before. He
mm,
said, I asked the question, why is it that that
mm,
same question has like the barrier of quantum tunneling? He
mm,
said everything in matter there has this tiny, tiny space
mm,
that it can like, let me say this is a solid. It's
mm,
vibrating, but the vibration is low. Why? Because the molecules, or let me say the particles are packed together.
mm,
You get.
mm,
So he said something like particles. There are. Let me say this is a wall, a cement wall. Let me say these are the particles. There are this tiny space
mm.
that a particle can pass through.
Yeah.
So that's why, let me say, that's why particles can pass through and go over to the other wall, because they are doing vibrations.
Okay, 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 okay,
There
okay.
are tiny space that also enables it to pass through
Okay,
and go
understand,
out.
understand.
You
Okay,
get.
that is actually tunneling.
Yeah.
Okay, so moving forward, can you explain? I've been hearing about double slit experiments. Double slit experiment. Can you?
I don't really
Okay, you
know
don't.
about double
Okay.
split. Or
Um, what about Bayes inequality?
I don't want to say much on it until I've.
Okay, until so there's this sweet stuff in quantum physics, and it's still weird to me that like all these principles now can happen, but when you observe it, it will not happen. Like, is that something?
That's why. Let me say
Eh,
that's why it's still hard to. It's still a hard nut to crack
in quantum physics, I not crack.
in
Yeah.
quantum physics
Mm,
because I saw something that said that
Mm.
that even even in that quantum level that when heat is high or low, it can just disappear.
Sorry, can you
When
be more audible?
okay, like
Mm.
I saw something that says that
Uh,
maybe in a quantum state, like in a very tiny state, if the heat, let me say the heat or energy that is around that place, whether if it's high or low, it can let me say it can trip off the
okay,
action. Like
okay,
let me say
okay, okay,
it's still very unstable to like hold on to or
okay,
like
okay. The that means the observer effect is the heat.
no, like let me say if it is not in a favorable condition,
It will
you
not
get
happen.
yeah. So it's see that's why I say kind of how to grab onto quantum.
Okay,
Yes,
okay, okay,
if it's not in a favorable condition, you cannot really. So it's something like you cannot really. You are seeing it, but you cannot really.
okay. I understand, I
Yeah,
understand. I think they call it the Copenhagen effect. So this one now is just equation. I just came now. I don't know whether God just sent it. So how does vector calculus or linear vector calculus, linear vector calculus.
and to some extent,
So how is it, like, can you explain how it concerns quantum physics? Like, why the fuck are we studying linear vector calculus? Like,
linear vector calculus.
yeah, what we did in
Okay, okay.
in
Linear vector calculus is on this differentiation or integration stuff.
like there are more semester tutors this
Like,
semester
oh,
on the one you are explaining on the board that time.
on Deche.
And that's it.
Okay, vector calculus.
Yeah.
To be honest, I've not even seen the relevance. I've not seen the relevance.
I said, well, I'm like, no, so that's something I'm not asking Sha, but I'm like, how does this concern particles? How does
Those
what
metrics, something,
what is even the
or
words he used to use,
is it to normalize the
normalize
eigenvalues?
eigenvectors, eigenvalues, stuff like that. Like,
I've not really seen the.
but like that's something you're very, very good at. Like, you used to explain to us.
Yeah, I
That's
can
what,
solve it, but
okay. So okay. So I think there's nothing here again, but can you explain uncertainty principle?
okay.
Like, bro,
To my best of
and if you
knowledge,
can like just really explain how the wave and particle side, like how wave and
okay.
particle, like,
I
yeah,
made a reference before to the fan,
to the to the
to
fan.
a
Okay,
ceiling fan.
okay.
Uncertainty principle is like something like uncertainty means I am not certain of where something is. I am not certain of something.
Mm.
So that's where the word uncertain comes from.
Uncertainty, yeah,
Yeah.
yeah.
So uncertainty principle means that the position on let me say in classical terms now, it says that the position and momentum of an object cannot
Mm.
be determined simultaneously.
Mm.
So either you find the position or you find the momentum.
Mm.
You not the both together. So let me say when we bring it home to quantum, we cannot really ascertain the position of a particle.
Mm.
Momentum is the speed at which it goes, you get, because particle, let me say, we have that what we call duality of matter, behaves
Yeah,
as waves
and
and
as particle,
particle.
yeah.
Yeah,
Mm.
in some instances,
Mm.
it will behave as particle.
Mm.
In some instances, it will behave as waves. So
Waves,
it's
yeah.
not something you can just this is a position this with speed of this.
Yeah, it's not. It's very
It's
hard to measure. Yeah.
yeah,
Okay.
very hard.
Okay. So talked about your love for nuclear physics,
Yeah.
and you said like he has link to quantum physics. Or what is actually the link of nuclear
Okay.
physics
The link to nucleus actually is quantum computing.
from nuclear to quantum physics?
Yeah. No,
Quantum comp.
quantum physics is the basis of understanding quantum computing.
Yeah.
So let me say the link there is that most of these let me say most of these
Okay.
nuclear bombs.
Mm.
Let me not go to let me see now, for example, most of these nuclear bombs now,
Mm.
they work with all these encryption codes and stuff,
Yeah. Yeah.
you
Yeah.
get.
Yeah. Mm.
So when quantum computing
Mm.
is being applied, it makes have you heard of something like say somebody infiltrated your camp and diffused a bomb or
Yeah.
something like that?
Yeah. Yeah. Okay. Okay.
So using quantum computing, you can structure a code that makes it.
Okay. You're
You
talking about
cannot
the
decrypt it.
cryptography. Yeah. I
Yes,
understand.
you cannot decrypt it.
Mm.
You
Mm.
get.
Mm.
So it makes hacking hard.
Mm.
So it makes a nuclear base station solid and it's not it's like let me say infiltratable. Why?
Mm.
Because it's not something you can meddle with. Yes,
Okay.
so that's why I say both of them are
Yeah, I
that's fine.
understand.
In as much as they're building, but you have to safeguard it
Okay.
because it's a very deadly something.
Yeah, I'm actually very excited that you are talking about quantum computing. Like, it's very like means that you have like deep research that you have done
Mm.
researches out. Development.
I was researching on something, so I
Uh,
was like,
mm,
is it possible to build an invisible
invisible doom.
dome, like something like this is Nigeria now.
Uh,
Let me make reference to Nigeria,
okay, very interesting.
and I can build. Let me say, I can build an invisible dome, like something like dome, like to cover
Yeah,
a particular place, so that it cannot be, it can be infiltratable.
it can or it cannot.
On you cannot fit like
It cannot like it can,
filtrate or penetrate or enter.
wow.
Like let me say like missiles or whatever. Highest, like it will form as a like an elastic barrier. Highest, maybe for example, when a
Okay,
nuclear bomb, for let me make for example, when a nuclear bomb lands on a dome, you can just
okay.
maybe create as just the way elastic water is elastic and
Yeah, yeah.
just like
That's
and
one.
bounce back.
That is actually very very like very mind blowing
You can just
stuff.
bounce back
Wow.
or something like this. Let
But
me
if it should be like this, that means waves can never penetrate. It's not videoing. Okay, sorry. Let me check. Yeah, actually videoing. But just the if stop just like okay, I'm actually still videoing. So can you just like continue?
okay, so
Mm,
or let me say something like when just like Hiroshima now, it's still
mm.
not actually a livable
Okay,
state.
what I was saying was that if that stuff should be there, waves can never penetrate into Nigeria. That means we'll not be getting information from US or like
No, not information. Like something like a strong invisible dome that cannot allow
anything at all or just
um,
nuclear.
anything nuclear. Like
Okay,
instead of
any
entering
weapon.
yes to come and it will bounce back. Like something like you know
What principles do you think can be applied here?
I'm still researching. This is what I had in mind before, but
Okay, okay,
I have to still
okay, of
like but I
course.
think what will work here is first of all, I think I have to work on
Mm,
knowing the know to even know the components of a bomb.
yeah,
You
for a
have to
bomb,
know what you are fighting
nuclear
why
bomb. Yeah,
fighting against. Yes, know the
yeah.
component of a bomb.
Mm,
Maybe kind of come up with something that let me say just the way just the way positive and positive repels. Come up with
okay, okay, okay,
something
okay,
that
okay,
will
okay.
repel.
Oh, that's very interesting. Point something that repair like the
Yes, yeah.
yeah, that's crazy.
Come
That's
up with something that will repel it. So instead of
do you think okay the only way this intercepts bomb is like when
when you
another
shoot it down.
yeah another okay
Yeah,
that's this is a very like mind blowing stuff. I think maybe in future
I pray.
they can like
I
do
hope
some
so.
research.
So you get
So okay so is there anything you want to like add? I think you're running on course. Batteries on zero. Is there
is
anything you
it
want to
add on what?
say like about physics about like
Okay, I would say
uh,
physics is hard for those that wants to be hard for,
but you enjoy physics?
but I enjoy physics.
Wow, so you come out with first class in physics.
Unlike in secondary school, then
Uh,
I can have an exam 2/60.
hmm,
I swear to
Jesus
God.
Christ. Calma. Wait. Was it okay? Was precise that refined you, Abby? Like,
So
what do you think refined you? Like, you have to take my education serious. Like, you have to like very serious. What do you think was the factor? In case anybody.
naturally, I am intelligent,
Okay, okay.
but I had issues with. In fact, I had issues with some science courses. I'm
Mm.
good in math,
Okay, good
but
enough. Okay.
something like chemistry is even the worst. Something like biology,
Uh,
physics. At least I'm passing those ones, but physics was no, that one was
was
a
the
no
worst.
go area
Yeah. Okay.
because even our physics teacher at that time,
Mm.
she was. I think when we fail resumption test, if it's over 10, if you
Mm.
don't like from from 5, 6, 7,
Mm.
you will not be flogged. But from 1 to 4, if you have 2, 10 minus 2, 8.
You flop.
So I shall receive K till my SS2 second term.
Yeah.
I started understanding it little by little. I think it was that fear initially that physicists had.
Yeah, that was physics.
Yeah,
Physics is
physicists
hard.
had that.
Physics
So
is hard.
I've already accustomed my mind that if there's nothing I can do to understand physics.
Okay.
So
Yeah.
from there, my first breakthrough was when I had a midterm quiz, 19 over 20. I was like, what's even there that I'm even
And you did not
afraid
use
of?
this for anything.
And I did not use Expo.
Wow, that's
I
crazy.
don't use Expo
Wow. Okay.
because even if I don't understand it,
Yeah.
I find something that is close to me that I can relate to it. So even if I
Wow.
understand something, I can look at it and remember
Yeah, yeah, yeah,
it's
yeah, yeah.
also this thing. Just the way this fan is now, I cannot forget
Yeah.
quantum this thing. Yeah,
Principles are
principle,
qualified.
uncertainty principle.
Yeah,
Yes.
yeah, yeah, that's very
Yeah.
crazy.
This is not hard actually.
Okay, so what can you like say to people that are finding physics very, very difficult? What can you say to them like?
Okay.
Yeah,
The only thing I can say is that first of all, you have to say within your mind that this is not hard because you
this is
have
so
to
hard.
determine. If you don't determine, there's nothing nobody is telling you that you agree.
Yeah, okay.
Then I have that phones, we have
Mm.
laptops,
Alex, still doing okay.
we have laptops.
Yeah,
Make use of your phones. I use ChatGPT.
ChatGPT.
Anything I understand, I'll tell it. Explain so in a layman understanding as if you're explaining somebody that does not
Okay,
know
that's what you say
physics.
ChatGPT every time.
Yeah?
Okay. That's what you should prompt ChatGPT to give you.
Yes.
Wow, that's very crazy. That's
I'll tell you, explain it to me.
in
And
a
even if
layman.
it does not, I'll say it, explain it the way you explain it to a 10-year-old. So it will bring it on my face. Oh yeah, look at this thing.
Mm.
Let me say, for example, now that's how I knew about this
Fun.
semi-fan
Wow,
something. Yes. So
wow.
it made reference to it now, so I can understand that as this fan is rotating,
Mm.
I cannot say one blade is here and say the speed at the same time. And something like also this superposition,
Yeah,
three of them are existing at the same time. You
yeah,
get
yeah, yeah, yeah,
so
yeah. So
when you
one.
now understand, and
Okay.
then another thing is that we have physics terms. If you don't understand it, get
Mm.
somewhere and write it down.
Mm.
Like most of this, every course has its own vocabulary or its register.
Yeah.
If you don't understand anyone, just jot it down in your own convenient time. Find the answer to this. Or if I'm reading something now,
Mm.
I saw something. I think it's detractor or something that is called. And I was reading stress actually. What stress is?
Stress.
I was not understanding what stress was.
Yeah, I didn't understand it too. So I remember like it was
So I
crazy.
had to ask ChatGPT
ChatGPT. Yeah.
what is stress and what is strain.
Mm.
So he now made so it made reference to me to a rubber band.
Rubber band.
Yeah.
Okay.
Imagine I have a rubber band.
Mm.
This is a rubber band.
Okay.
This is a rubber band.
Mm.
And I'm stretching it.
Yeah.
Yes. It's if from this I learned poison ratio effect.
Please, I need to learn that
So
stuff.
I don't need to go
Okay.
through it again
Okay. Okay.
and
Okay.
understand
Okay.
poison
Okay.
this thing.
Yeah.
Okay, let me say poison since it's the easiest one.
Yeah. Okay.
Poison ratio says it is the decrease in the thickness of a material
Mm.
when it is being stressed or strained. So I was like, how?
So I didn't get what poison ratio is.
Like it's the ratio of the decrease in thickness of a material
Okay.
to its extension. So that
Okay.
sentence means as I am extending this thing,
Mm.
it will be like this.
Yeah.
This place that the thickness has decreased. So as I'm
Yeah. Yeah.
stretching
Yeah.
it
Yeah.
more, it is decreasing. So it's the ratio of the
Okay.
decrease.
Can you write the ratio? Can you just like write it from the?
I think it's something like this minus EYY over EZZ, something like this. So as
Okay.
I'm stretching it now,
Mm.
this is the way it was before.
Yeah.
As I'm stretching it, it reduced.
Mm.
As the extension is going,
Okay.
as the extension is expanding, it is
It's
still,
still
yeah.
still.
So that's
So
just
can
poison
you
effect.
like this equation? Can you like give us how it's represented here?
It's actually a long, it's not
Okay.
something I can start now.
Okay. Okay.
It's a long something.
Okay. But it's actually like very
Yeah.
interesting. Wow.
And for stress now,
Yeah.
He said, okay, it's also made to a, let me say, a slab of an elastic material.
Okay.
So when I'm stressing it,
Mm.
stress causes strain.
Yeah,
So
like
stress
yeah,
is,
increasing length.
if I apply stress on it now,
Yeah.
there it is connected to each other.
What's connected?
This slab of an elastic material,
Okay.
they are connected to each other.
Okay.
Just like if you are drawing cheese now, those tiny tiny lines that are holding on to
Okay.
each
Okay. Okay.
other,
Okay. Yeah. Yeah.
that's
Yeah.
what is happening here in the microscopic level that we
Okay.
cannot see with our
Okay.
naked
Okay.
eye.
Okay.
So when you are stressing this thing now
Mm.
and you are drawing it, just check, imagine cheese when you are drawing it, that thin line.
Yeah.
So they are trying to hold on to each other.
Yeah. Yeah. I understand.
So
Mm.
when that stuff weakens,
Mm.
then that means it cannot actually go back to its original
So
form
that is like
again.
the breaking point.
Yeah, so it is breaking inside little by little. Those tractions are holding themselves. Little internal tractions occurs first before you now see the outer one that
Ah,
will now cause.
that's really okay.
Yeah.
Wow.
So if you understand it like this, you understand stress.
No,
You don't
that,
need to go
that,
through stress.
so this was Shalibi that explains this to you.
Yeah.
Wow. Wow. Like seriously, like, even that position ratio, like as I was ringing in my head, like position ratio, I don't understand it, but now I explain it. Like
Even bulk modulus safe.
explain Buck movies.
So all this physics are interrelated. You have to
Physics is sweet. I don't
understand.
know why people don't like physics. Like
Okay, even bulk
it's actually
modulus.
this funny level that I started enjoying physics. To be
Okay,
honest.
this bulk modulus
Uh,
now is something like bulk modulus is something like I
mm,
have a body.
mm,
I have a body like this.
marker is even okay. Can you do the marker like this? So
I have a body like this now.
yeah.
You understand?
Mm,
So bulk modulus is, let me say it in a layman, let me leave the physics terms.
mm,
So bulk modulus is that this material, like let me say this is a solid metal block that I know
okay.
that is very hard to compress.
Okay.
So bulk modulus is what is if this thing is very hard to compress, that means it has a high bulk modulus.
Okay.
Ability to compress something. That's
Okay.
just that in bulk modulus
Okay.
always.
So bulk mode is not applied to elastic material.
It's still if you bend, and elasticity, if you bend itself, it will still shorten. Even if say
Okay.
you
Okay. That is
stretch it,
okay. Okay. I
yes,
understand.
all
Yeah.
of them
I'm
are
not
still
using,
elasticity.
okay. I'm not
Yeah,
using
yeah,
the
yeah.
advanced stuff again.
So this for the if this thing is no is if this thing will be hard to compress.
Mm.
So that means this thing has high
Hey,
bulk
bulk mode.
modulus. But if this can now, this empty can, I
Yeah.
can compress it. So this bottle has very small bulk modulus.
Yeah. 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 I
So
understand.
it's the ability for a body like that constant.
Okay. So the higher the
The
bulk modulus,
the higher the
the
body it
harder
is to become. That's
compress.
why you have something like
So I'm like, can you, what if can I, once the bulk point is high, how can it reach the breaking point? How can the material reach the breaking point?
if a bulk modulus is high,
It's very high. That means it cannot reach the breaking point. I mean, that
it
means
will be very,
very
very,
hard
very,
to.
very hard.
Okay. Wow.
That's why
That's
you need to have more energy, or depending on what you are compressing it or doing
okay. Yeah.
anything
I
with
need more
it.
energy. Okay.
Yes.
Wow.
So that's why they say that's why you have incompressibility is the opposite of bulk modulus, 1/k. You get.
Now,
So
now that I wish our lecturers could just teach like this. I wish our lecturers could just like explain, give this kind of. I
the
don't even know
thing is
why.
just to go home
You
and,
just okay, go home and
yeah. When I read, I don't just read because if I say a lie, I don't understand.
eh,
I saw bulk modulus. I've been
eh,
hearing it before, but I don't understand it.
eh.
So I want to charge it to explain this thing to me in layman understanding. Use examples at home that I can understand
Wow,
to give it to me, and I'll read it and I'll jot it down. I've learned that one.
wow, wow,
So that I make use of my resources very, very well.
wow. That's great. Like I'm so happy I had this interview
So
with
in conclusion is for
you.
this quantum mechanics,
Mm.
anything you don't understand, just
Just
break it to me as you're breaking to like to
as
explain it
a
to a small
with home
child.
materials, yeah.
Yes, to hold materials, it will explain it to you in
Okay.
the way you don't understand. Sorry, in the way you understand.
Sound
Then you
okay.
not bring it to physics this thing.
Thank you very much for honoring this my interview and yeah, we might see another time.
No problem.
And those equations, like, I wanted to like
The
explain this,
equations.
like how you explain this one. Like I just wanted
Yeah.
to basically for me because exam I need that equation. So
Mm.
thank you.
Thank you. You're
Like
welcome.
this present. So bye bye. You can say bye bye to the camera. This will die.